So well done on your work yesterday for plotting scatter graphs or scatter diagrams. This generally seemed to go pretty well. They're not too taxing to do. I think a lot of the time they kind of make a bit of sense. What we're just going to do today is a little bit of practicing of interpreting these scatter diagrams. So here we've got a question. So some rugby players take two tests, one measuring speed and the other measuring strength. Each test is marked out of 200. The scatter graph compares the results. Let's just remind ourselves about what that means. So this person here, well, they scored 40 on test 1 and 120 on test 2. So we can see general things about this. So we know if we think about the correlation, there seems to be a strong negative correlation. So I might get asked that in an assessment to describe the correlation, and I would say there was a strong negative correlation. Need to use that vocabulary. I'm saying strong because they pretty much form a line. They're not too spread out from one another. I can pretty much draw a line down. So we should be comfortable with doing that now. So the next step is I might get a question that looks something like this. Brian scores 40 in test 2. Estimate his score in test 1. Now, there is one key method for doing this. What we can't do is just estimate. You're not going to get any marks in an exam if you go, right, well, 40 in test 2, remember making sure to read that, so it's 40 in test 2, it'll be roughly, I don't know, about there, maybe if I'm using that there. But we cannot use that technique. You will not get any marks for doing that. What you must do is draw what is called a line of best fit. And like the last few times I've been doing these with you, I have kind of said, look, it's about, imagine we could draw a line to represent kind of what's going on. And that's exactly what we're going to do. A line of best fit is a straight line, so drawn with a ruler. And I'm basically going to draw it through to make it so it represents this as much as possible. So I should have it going through as many points as it can. And if that's not the case, then making sure that the roughly the same number above it as they are below it. So I'm going to try that. So the best thing to do is get your see-through ruler and just position it until you think that's the case. So something like that would be just about all right. It goes through quite a few points. I've got like a couple above. I've got basically 3 above, 4 above and 3 below. So I reckon this is pretty representative. One thing you will notice with these questions is that you are unlikely to get exactly the same answer as the person next to you. All right, because our lines of best fit will all be slightly different. They'll all be roughly the same, like they shouldn't look too massively different from one another, but we are going to likely to get some different results. So that is going to be step 1. So if I get a question like this, it's not going to tell me to draw a line of best fit. I just have to know that I do. So scatter graphs and lines of best fit, you should know, you should make the connection in your mind that they go hand in hand. Okay, so let's actually answer this question. So Brian scores 40 in test 2. Estimate his score in test 1. Well, that's 40 that I've already circled. So again, I'll probably with my ruler, because this is awful on here, it's not too bad, go along to my line of best fit. And then I'd read down and I'd get roughly, so that would be 100 and, well, each square is worth 4, so it'd be 132. And that would be my answer. Again, because our graphs will all be slightly different, you'll be given a bit of leeway each way. You could probably get, I don't know, 128 up to 136, something like that. In an actual test paper, they'd be very clear about you have to have drawn a line of best fit, otherwise you won't get the marks. And secondly, you can have slightly different answers for the end value. So here's another quick example. So we've got the value of cars in a garage and how long they've been in there. So another car arrives at the garage, is 4 years old and worth 5,000. Show this information on a scatter graph. So that is going to be, so 4 years old, 5,000 here. So it's going to be there. All right, so that would be 1 mark. Describe the correlation between the value of the car and the age of the car. So it is a negative correlation because it's going down. So I know straight away it's a negative correlation. And it is fairly strong. And you know what, I'm actually just going to write that. So fairly strong negative. It's not making a line like the other one did as well, but it's also not too spread out. So it's a fairly strong negative correlation. So again, that's probably going to be a mark. Right, again, so the next car that arrives is 6 years old. Estimate the value of the car. It is not telling me to draw a line of best fit. I have to know that that's what I have to do. So let's draw a line of best fit. And I reckon that'll probably do. It's not going through many points at all, but it kind of is pretty representative of what's going on. It's not perfect, but I think it's pretty representative of that data. Okay, so the next step, let's actually answer questions. So the next car that arrives is 6 years old. Estimate the value of the car. Well, here is 6 years old. So I'm going to use my line to estimate the value. So I would actually draw this on in an exam to show the examiner exactly I know what I'm doing. Read across. Again, you'll be able to do this more accurately. So that would be £3,800 roughly. Again, you'd be given a little bit of leeway in a paper. So if you can go away now and practice those with the given questions, and let me know if you need any support on the Google Meet.